This presentation will demonstrate how to develop the simulation scheme for the hydraulic plant. It consists of two parts. The first part is the transfer function GP2, and the second part is the transfer function GP1. The input is the control variable. This is actually the flow into the first tank, and the output is the level in the third tank. There is also the disturbance, which accesses the process in this midpoint. The MATLAB is opened. This figure shows what we have to do actually. So we need one transfer function for the realization of GP2. We need another transfer function for the realization of GP1. We need one block for summing. Then we shall also simulate the input signal with a step signal. We shall also simulate the disturbance with a constant signal, and we shall observe simulation results with a scope block which will be connected to the output of the plant. Now I open the Simulink library. I open the new model. And now I must find in the Simulink library appropriate components. I will start with continuous library. In this library I can find transfer functions. This is the transfer function which will be used for GP2, and I will use another two transfer functions. This will be used for the realization of GP1. Then I will open the math operations. I will use the component for adding signals. Then I will open sources. I can find the constant signal. And I can also find here the step signal. And I need also the things library to find the scope block. Now I will slightly rearrange the positions of these blocks. And I will connect these blocks. The input signal goes to the first transfer function. And the output of the last transfer function is actually the plant output, and it will be observed with scope block. The disturbance is simulated with this constant signal, and it influences the process in this point. Now the parameters of the components must be defined. I open the step function. The initial step time, or the default value, is 1. I will switch to 0. The initial value is 0. The final value is 1. So we shall test the response of this system on the unit step function. This value defines the disturbance. For the first experiment, it will be set to 0. This transfer function represents the first transfer function GP2, so the numerator should be put to 0.5 and the denominator to 5 and 1. So this is correct. The second transfer function will realize this first part of the transfer function GP1. That means the numerator is 2 and then denominator 10 and 1. The second transfer function realizes this part. the numerator is 1 and the denominator is tan 1. So this is correct. And now we can start the simulation. Let's open the scope block. I will press the auto scale button. What we see that the response in 10 seconds is not enough. So we shall increase this value to 50 and repeat the simulation. Let's try with 100. So we obtain now the transient response of this hydraulic system to the unit step input signal. The largest time constant is 10. So as our simulation time was 100, we actually select the simulation time being 10 times greater as the largest time constant. And we can also see that the gain of this process is 1. As the input signal was 1, the final value of the response is also 1. Now let's analyze the influence of the disturbance. Therefore, I will put the input signal to 0 and the disturbance value to 0.5. This is also the value which will be later used in the simulation of the control scheme. I can start the simulation. What can I observe? The level increases for 1 meter due to this disturbance. And this is the disturbance as the change of the level in the first tank. So in the first tank, the level is changed for 0.5 meter, and in the third tank, the level is therefore, due to this disturbance, changed for 1 meter. While the gain of this path is 2, but as the disturbance signal is 0.5, then it's correct that the increase of this signal is 1. We can also change the background color of the blocks which realize the process. Format, background color, custom color, and I will select this green color. Finally, I will save this Simulink model and I will select the name, process point SLX.